Today we are talking about volume of prisms. Prisms are classified by the shape of their base. So we've got a triangular prism. This is also a triangular prism. We've got a hexagon base here, so that's a hexagonal prism. We've got a rectangular base, so this is a rectangular prism. Lots of different kinds of prisms. All right, volume is three-dimensional. So whenever you do volume, you always label it cubed. Area was squared, but volume is all the stuff that can fit inside, so it is cubes. Cubed, base times width times height, the entire thing, how much it can fit inside. All right, so volume is classified with a capital V is what we use to explain volume. And we can find volume of any prism with all the same formula. You take the area of the base, the capital B is the area of the base, and you multiply by the height. So basically you are finding this red area here and multiplying by how many of those areas are stacked on top of each other. Let's find the volume of this prism. We have got 6 yards by 8 yards by 15 yards. So our base is the area of whatever side we choose to be the base. In this case, I'm going to choose this side here. So it is 6 times 8. So our base equals 48 yards. Okay, so our equation was volume equals the area of the base times the height. If our base is 48, our height is 15. So we can multiply that. .48 times 15 equals 720. We need to label that yards cubed because area is how much can fit inside. It is the length times width times height. So we are cubed. All right. Also, you can use this formula for rectangular prisms only. Length times width times height. And the reason that you can do that is because length times width is equal to the area of your base. Let's find the volume of this triangular prism. This side here is going to be our base, the triangle-shaped portion. All right, so volume equals area of the base times height. And area of the base, we have to find area of that triangle. So area of a triangle is equal to 1/2 base height. And when I say base here, I mean this distance right here. And height is the height of our triangle. So area of our triangle equals 1/2 times the base, which is 5.5, times the height, which is 2. So area of our triangle equals 1/2 times 5.5 times 2 is 11. So area of our triangle equals 11 divided by 2 is 5.5 inches. This is squared because it's an area. This is equal to B. Area of a triangle is equal to the area of my base. So we take the area of that triangle, substitute that number in for our base. So it is 5.5 times the height of our prism, which is 4 inches. All right, 4 times 5.5. 0.5 times 4 is 2, because we have 1/2, and another half, another half, and another half. 4 halves, that's 2. And 4 times 5 is 20. So we add those together and we get a volume of 22 inches cubed for the volume of this triangular prism. We can also use volume of a prism to find a missing piece of the prism. We don't know what the height is on either one of these backs, okay? So it tells us that each one of these holds 96 cubic inches of popcorn. So that is our volume. Our volume equals 96 cubic inches, or inches cubed, of popcorn. So they both hold the same amount. We need to find the height of the bag, of each bag. Therefore, what we're going to do is, we know that the base of this bag is 3 times 4, which is 12. That equals my base of this bag. The base of this bag is 4 times 4, which equals 16. We can take our equation, volume equals the area of the base times the height. I know what the area of each base of these is, so I can substitute my volume in and my base in. We'll do this one first, and I can solve for the height. 96 divided by 12 equals 8. So I know that the height of this bag is 8 inches. We can do the same thing to solve for this one. I know that my volume is 96. It holds 96 cubic inches of popcorn. I know that my base is 16. And I can solve, the area of my base is 16. I can solve for my height if I divide by 16. So my height equals, my brain's not working the best, so we're going to use a calculator here. 96 divided by 16 equals 6. So the height of this bag is 6 inches for our height. Okay, so it wants to know for B, which bag should the theater choose to reduce the amount of paper needed? So in order to solve this, we're going to have to use our area, our surface area, but we're not going to solve for the top because the top of the bag is open. I want you guys to go ahead and solve B here on your own. Which bag should the theater choose to reduce the amount of paper needed? Good luck. We'll talk about it in a class.